Using multi-head latent attention, MHLA, in day trading involves leveraging a machine learning model that can capture complex patterns and relationships in financial data, particularly by focusing on relevant features or time steps. MHLA is an advanced attention mechanism inspired by the transformer architecture, where multiple heads focus on different parts of the input sequence simultaneously. This allows the model to capture diverse dependencies across various temporal or feature dimensions. Here's how you could potentially use multi-head latent attention in day trading. 1. Data collection and pre-processing. Historical data. Gather historical price data, e.g., OHLC. Open, high, low, close, volume, technical indicators, e.g., RSI, MACD, Bollinger Bands, and any other relevant market data. Feature engineering. Create additional features such as moving averages, volatility measures, momentum indicators, etc. Normalization. Normalize the data to ensure all features are on the same scale, which is important for neural networks. Time series segmentation. Break the data into sequences, e.g., past 60-minute windows, that the model will analyze to predict future price movements. Number 2. Model architecture with multi-head latent attention. The core idea behind using multi-head latent attention in day trading is to allow the model to focus on different aspects of the input data, such as specific time steps or features, to make better predictions about future price movements. Key components. Input layer takes in the pre-processed time series data, e.g., prices, volumes, technical indicators. Embedding layer converts raw inputs into dense vectors that the attention mechanism can work with. Multi-head attention mechanism. Each head focuses on a different part of the input sequence or feature set. For example, one head might focus on short-term price movements, while another might focus on longer-term trends or volatility. Latent space representation. After passing through the attention heads, the model aggregates information into a latent space representation, capturing key patterns and dependencies. Fully connected layers. These layers take the aggregated latent representations and output predictions, e.g., whether the price will go up or down. Example model architecture. Python. Import TensorFlow as TF. From TensorFlow to Keras, layers import input, dense, multi-head attention, layer normalization, dropout. Hashtag define the input shape, e.g., 60 time steps with 10 features. Input underscore shape equals 60, 10. Inputs equals input, shape equals input underscore shape. Hashtag multi-head attention layer. Attention underscore output equals multi-head attention. Number underscore heads equals 8. Key underscore dim equals 64. Inputs. Attention underscore output equals dropout, 0.1. Attention underscore output. Attention underscore output equals layer normalization. Epsilon equals 1.6. Attention underscore output plus inputs. Hashtag fully connected layers. X equals dense, 128. Activation equals relu. Attention underscore output. X equals dropout, 0.2. X equals dense, 64. Activation equals relu. X. Outputs equals dense, 1. Activation equals sigmoid. X. Hashtag output. Probability of price going up. Model equals tf.keras. Model. Inputs, outputs. Model.compile. Optimizer equals atom. Loss equals binary underscore cross entropy. Metric sad face, accuracy. 3. Training the model. Labeling. Define your target variable. For example, if the price increases in the next time step, label it as 1 by signal, otherwise 0, sell signal. Loss function. Use a loss function appropriate for your task, such as binary cross-entropy for classification tasks, bias sell signals, or mean squared error for regression tasks, predicting exact price changes. Training. Train the model on historical data, ensuring you use techniques like cross-validation to avoid overfitting. 4. Inference and decision-making. Once trained, the model can be used to predict future price movements based on real-time or recent data. Attention weights. You can inspect the attention weights to understand which parts of the input sequence or features the model is focusing on. This can provide insights into what the model considers important when making predictions. Trading strategy. based on the model's predictions, implement a trading strategy. For example, if the model predicts a high probability of the price going up, execute a buy order. If the model predicts a high probability of the price going down, execute a sell order. 5. Risk management. Position sizing. Use risk management techniques to determine how much capital to allocate per trade. Stop loss and take profit. Set stop loss and take profit levels to manage risk and lock in profits. Backtesting. Before deploying the model in live trading, backtest it on historical data to evaluate its performance under different market conditions. 6. Continuous learning and adaptation. Financial markets are dynamic, so it's important to continuously update and retrain the model with new data. Monitor the model's performance and adjust hyperparameters or architecture as needed. 7. Potential benefits of multi-head latent attention in day trading. Capturing complex patterns. The multi-head attention mechanism allows the model to capture both short-term and long-term dependencies in the data. Feature importance. By analyzing attention weights, you can gain insights into which features or time steps are most influential in the model's decision-making process. Flexibility. The model can be adapted to different types of financial instruments, stocks, forex, cryptocurrencies, and time frames, minutes, hours. 8. Challenges and considerations. Overfitting. Financial data is noisy, and models can easily overfit to historical patterns that may not hold in the future. Market regime changes. Markets can change regimes, e.g., from trending to sideways, and the model may need to be retrained or adjusted accordingly. Latency. In day trading, execution speed is critical. Ensure that the model can make predictions quickly enough to act on them in real time. Conclusion. Multi-head latent attention can be a powerful tool in day trading by allowing the model to focus on different aspects of the data simultaneously. By training the model on historical data and using it to predict future price movements, you can develop a robust trading strategy. However, it's essential to combine this approach with sound risk management and continuous model evaluation to adapt to changing market conditions.